Yes, can you see the screen?
Yes, ma'am.
Yes, ma'am.
Okay, let's continue. So, bar graph, yes, Anand, still I have not taken with you. The first three questions is related to bar graph. Towards the last of the class, I'll finish that one. Let me finish the remaining questions from the exercise. Concepts I have taught you, but I need to show one by one questions that, yeah, we are done with this question, or maybe we are not done with this question. So, just a moment. Yeah, 12.1 is there. 1, 2, and 3, nothing, just bar graph is there. I'll take that. Question number 4. Last day we were discussing how to make the. Yeah, the question says that draw histogram. Last day we have already done this one, right? Part 1.
Yes, ma'am.
Okay. Part 2, I said that you can try later. So, is there any other suitable graphical representation for the same data? So, we understand when we are having a group data. This is not continuous. However, we have made this data continuous. And after that, we have plotted histogram. Another possible way to represent the data is frequency polygon, because we are having continuous group data now in hand. So either we can do histogram or frequency polygon. Bar graph, we don't draw bar graph with the continuous group data. Okay, group data will give you histogram or frequency polygon. Bar graph looks like this. Okay, the data, the bars are separated from each other, right? That's called bar graph, right?
Yes, ma'am.
Yes, ma'am.
Okay, so here the other way to represent the data is frequency polygon. Do we have to represent it? It doesn't say. It just says that is there any other suitable graphical representation? So we will say, yeah, there is another suitable graphical representation for the same data, that is frequency polygon. Clear?
Yes, ma'am. Yes, ma'am.
Do we have to write just one statement and we are done? Yeah, we do have to write just one statement, and yes, we are done. Okay, let's do the next one. Number 3. Is it correct to conclude that the maximum number of leaves are 153 millimeter long? So I think we have arranged the data and it looks like this. 117.5 to 126.5. 126.5 to 135.5. 135.5 to 144.5. 144.5 to 153.5. 153.5 to 162.5. 162.5 to 171.5. 171.5 to 180.5, right?
Yes, ma'am.
Okay,
Yes.
so is it correct to conclude that the maximum number of leaves are 153 millimeter long? Okay, 153 millimeter long, maximum number of leaves. That means there are 3 leaves in this category, 5 leaves in this category. Okay, 9 leaves in this category, 12 leaves in this category. Okay, 5, 4, 2. So maximum 12 leaf is lying in between this category, right?
Yes.
Yes, ma'am.
Okay, maximum leaves lying in this category, which is 144.5 to 153.5. However, is it correct to conclude that the maximum number of leaves are 153 millimeter long? So if we are making group data, suppose I am having the marks of the student, okay, and the marks looks like this: 2 marks, 3 marks, 4 marks, okay, 4, 4, 4, 4, 8 marks, okay, out of 10. Okay, these are the marks of the students. These are the marks of the students out of 10. And if I'll make the frequency table with this data, the frequency table will look like this. Okay, marks and frequency. So 2 marks, how many such students are there who have obtained 2 marks? 1. 3 marks, how many such students are there who have obtained 3 marks? 1. 4 marks. How many such students are there who have obtained 4 marks? 1, 2, 3, 4, 5, 5 marks, right? Wait, here it is still clear. If I'll make the group data, no, then you will end up getting confused that which data is repeating itself maximum number of time. Suppose I'll write in between 1 to 3. In between 1 to 3 marks, how many students are there? Let me write it. One student. Okay, in between 3 to 6, how many such a student are there? So this is also falling in the category of 3 to 6, right? This also, this also, this also, this also, and this also. How many such data is there which is lying in between 3 to 6? 1, 2, 3, 4, 5, 6. 6 such data are there, right?
Yes,
Yes.
one student, 1, 2, 3, be 2 people.
uh 2 people, where is 2? I can
Because
see
one
the.
person got 2 marks, one person got 3 marks.
So while taking the data, okay, we don't take the upper limit, but we take the lower limit, right?
Okay, ma'am.
Okay, 3 is falling in the category of the next one, not the first one, right?
Okay, ma'am.
Okay, so due to that reason, I'm taking 3 in the other class interval. Now, in between 6 to 9, how many students are there? In between 6 to 9, so I'll take this 8 also, this 8, 8, 8, 8, 8. Okay, but I'll not take 9. I'll not take 9, right?
Yes, ma'am.
Yes, ma'am.
Okay, so 1, 2, 3, 4, 5, 6, 6 data. Suppose this, here you can see the raw data. Okay, if this raw data is not known to you, you don't even know anything about it, and you just know the table. Okay, so maximum number of data is coming from uh wait, here it is coming from 3 to 6 and 6 to 9 also. Let me decrease one of the data. One of the 8 I am deleting. Okay, here there will be 5. Now you can see the maximum data is coming from which interval, which class interval? 3 to 6, right?
Yes, ma'am.
Okay, and which data is repeating itself maximum number of time? Which data? If you don't have any information regarding this raw data, okay, you don't know how the marks, okay, how exactly the students have achieved the marks. Okay, here I have written by comma, 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 comma. If this is not known to you at all and just this table is given in front of you, will you be able to say which data is repeating itself maximum number of time? Yes or no?
No, ma'am.
Okay, you won't be able to say which data is repeating itself maximum. In between 3 to 6, which data is maximum number of time repeated? You won't be able to say. However, here since I have written the raw data in front of you, okay, you can see which data is repeating itself maximum number of time. 4. Okay, how many times 4 were there? 1, 2, 3, 4, 5, 6. 6 times, 5 times 4 were there, right? Yeah, 5 times, right?
Yes, ma'am.
Yes.
Okay, if you don't have any information regarding the raw data, then just by looking at the data frequency table, okay, 6 is the maximum frequency. That means maximum data is coming from this class interval. Now, in this class interval, which data is repeating itself maximum number of time? We don't know. Okay, we don't know, and we won't be able to say. So that's what we have to say over here. If it says that, is it correct to conclude that the maximum number of leaves are 153 millimeter long? No. Okay, we don't know which what is the length of the leaf which is repeating itself so many times. We don't know. Yes, it is coming from this class interval 144.5 to 153.5, but maximum time 153, 153, 153, 153, 153 is there. We are not sure about that, right?
Yes.
Yes, ma'am.
Okay, so we will write over there no. It is not correct to conclude that maximum number of leaves are 153 millimeter long. as we don't know from class interval 144.5 to 153.5, which data is repeating itself maximum number of time. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, let it come. Yeah, you can note down the answer. The second part, frequency polygon, is the other best way to represent the data. The third one's answer clearly I have written over here. Please note it down. And yeah, let me know once you are done. Are you done?
Yes, ma'am.
Yes,
Yes,
ma'am.
everyone. Are you done? Okay. Let's continue with the next question, number 5. The following data, okay, 400 neon lamps and all, represent the given data with the help of the histogram. I told you, you can do it by yourself. I believe you have done it, right?
Yes, ma'am.
Now it says that how many lamp have a lifetime of more than 700 hours. More than 700 hours. Here we will be able to find approximately more than 700. Okay, this class interval we will be taking, because you understand here 700 is there, fine, but more than 700 is also here only. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, so we
Yes,
have to
ma'am.
take this class interval. If you are thinking, but 700 is also there, and the question says more than 700. So yeah, approximately we will be able to find. Here 700 is there, but more than 700 is also there. If I'll exclude this one, there will be huge gap. Okay, so taking 2 3 extra, calculating 2 3 extra lamp is completely fine. Okay, we will be taking this particular interval, we will be taking the next interval to calculate more than 700, we will be taking the next interval to calculate more than 700 lamps. So how many lamps are there which is more than 700? We can say it is 74 plus 62 plus 68, that is it 204? Please check it.
Yes, ma'am.
Okay, so please do the next part, that the number of lamp, okay, which have lifetime of more than 700 hours are 74 plus 62 plus 68, that is 204. Is it making sense to all of you what we are doing exactly?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Okay, and if you are done, let's continue. Can we continue?
Yes, ma'am.
Are you done, everyone?
Yes,
Yes.
ma'am.
Yeah, ma'am.
No, no, please do it.
Yes, ma'am, done.
Yes. Okay, let's move. Question number 6 we'll be doing today. Okay, we have not done this one in the last class. The following table gives the distribution of a student of two sections according to the marks obtained by them. Okay, so section A marks you can see, frequency you can see. Section B, of course, marks will be same because we are talking about the same class. Okay, the question paper was same, the total marks was same. Okay, hence the class intervals are same. Frequency is different. Okay, so frequency over here, frequency over there. Now represent the marks of the student of both the section on the same graph by two frequency polygon. We have to draw two frequency polygon. So far I have not explained you how to draw the frequency polygon without help of histogram. Yes, I was explaining you with the help of the histogram how can you proceed. Without histogram, how can you draw? Let's see that. From the two polygon, compare the performance of two sections. So yeah, let's see. Just a moment. As we understand, for plotting the frequency polygon, we need to take the help of class mark. Okay, class mark. So yes, first of all, we will be finding the class mark. Directly, we can find the class mark over here. Can you see this screen, everyone?
Yes, ma'am.
Okay,
Yes, ma'am.
first of all, we will be finding the class mark. Here only you are allowed to find it because this class intervals and this class intervals are same. Okay, so class mark will not be different, it will be same for both the, okay, class intervals. Class mark, we write just class mark, that will be lower limit. Okay, the formula I'm writing, class mark formula was lower limit plus upper limit by 2. Actually class mark is nothing but just the midpoint. Okay, lower limit plus upper limit by 2. So let's do it. 0 plus 10 by 2. 10 plus 20 by 2. 20 plus 30 by 2. 30 plus 40 by 2. 40 plus 50 by 2. We are getting 10 by 2, that is 5. We are getting 30 by 2, that is 15. We are getting 50 by 2, that is 25. We are getting 70 by 2, that is 35. We are getting 90 by 2, that is 45. Please do it properly, like in front of each row. Properly you have to maintain the rows, okay? So this is how we are getting the class mark, okay? Let's see how to draw a frequency polygon without the help of histogram. So first of all, we will be taking the data. Okay, along x-axis we take the class interval. Our class intervals start from 0 to 10, 10 to 20. So 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Just that. Okay, and the frequencies are so many different number. 3 is there, 9 is there, 17 is there, 12 is there, 9, and over there 5 to 19, 15. So yeah, I am thinking about taking the gap as a maybe 2, maybe 3. I'm taking 2. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18. Is it making sense to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, now I'll be just plotting this data, this one. Okay, yes, these are two different data set is given in, okay, in one go. In one go, two different set of data is given. This is one data, this is another data, and yeah, coincidentally for both the data, class mark is same, because the same sections, like the same class different sections we are talking about, since our class intervals were same, that's why directly we have found the class mark. Okay, if you want, you can find the class mark separately as well. And now we will be taking the class mark. Okay, we will be taking the class mark and the frequency. So here I'll be taking the class mark and the frequency. Okay, this frequency I'll be taking first, this one. At first my motto is to in just represent the section A. For section A, I am going to plot the frequency polygon. At first, I am going to plot frequency polygon for section A. Okay, then I will be plotting the frequency polygon for section B. So let's plot it for section A. For section A, you have to take the class mark. The first class mark is 5 and the frequency is 3. So actually you have to locate from this class interval, 5 is here. Okay, and the frequency is 3. That means you have to go up and up. This is the point, okay, whose coordinate is 5 comma 3. Making sense?
Yes, ma'am.
Yes, ma'am.
Okay, this is our class mark. Of course we will be taking class mark along x-axis because our class intervals are along x-axis, and of course we will be taking frequency along y-axis because that's how we represent the data. Yes or no? Right. Next one is
Yes, ma'am.
15. Class mark is 15 and the frequency is 9. So now my motto is to represent a point that is 15 comma 9. Making sense?
Yes, ma'am.
Okay. So 15 is here. Wait. Wait. I'm doing mistake. This is not 5. This is by mistake. I ended up taking 15. 5 will be here. 5 will be in between 0 to 10. Okay, and 3 is here. So actually this is the point. Okay, this the bold one, it's 5 comma 3. Okay, please be careful what I am locating. 5 comma 3. Next is 15 comma 9. So here is 15. Okay, and 9 will be here. So this is the next point, the bold one. Is it making sense to all of you?
Yes, ma'am.
Okay, next one is 25. 25 comma 17. Okay, 25 is the class mark and the frequency is 17. So I'll be taking 25, I'll be taking 17, and somewhere here, can you see the bold one, the third point?
Yes, ma'am.
Next one is 35, that is class mark, and 12 is the frequency. So 35 and 12 is the frequency. 12 somewhere here. Yes, you have to take the help of ruler, scale, and pencil. Okay, you have to take the gaps properly, and then only you have to draw it. And the next one is 45 comma 9. So 45 comma 9. And now I'll be connecting all of them. Now let me tell you, don't try connecting it directly without the help of a scale. You need to put your scale, okay, along with 2 point A and B, and then you will be joining a line segment like this. Making sense?
Yes, ma'am.
Yes, ma'am.
And you will be just placing your scale along with B and C, and then you will connect them like this. Okay, then C and D you will be connecting like this. Okay, then D and E you will be connecting like this. It may look like, okay, it can be any way, but you have to connect it properly with the help of the scale. Okay, at a time 2 points you will be taking, only 2 points. We are almost there, we are about to get frequency polygon, but this is not polygon. Okay, we have to make it polygon. Making sense?
Yes, ma'am.
Okay, to
Yes,
make it polygon, what we will do, we will connect it. We will try connecting the end point A with the x-axis and the end point E, the last one, with the x-axis. And how we do so? By creating a virtual class interval. Initially, okay, before the first class interval, we create a virtual class interval, and after the last class interval, we create a virtual class interval by taking the frequency, assuming the frequency as a zero. Nothing is there as a frequency, right?
yes, ma'am.
Okay, let's create it. So the first class interval is 0 to 10. Before that, if I have to go, I'm thinking about the upper limit must be 0 and the lower limit can be minus 10. Minus 10 to 0. And the class mark for this one will be minus 5, right? You can check it with the formula as well. Okay, upper limit plus lower limit by 2, upper limit plus lower limit by 2. Okay, that is negative 5. Yes or no?
Yes, ma'am.
So the point is minus 5, the class mark. And what about the frequency? It's 0, because this is virtual class interval we have created. Here nothing is there as a frequency. So the point will be minus 5 comma 0. Making sense?
Yes, ma'am.
Yes, ma'am.
Okay, somewhere we are having minus 5, okay, towards the left of 0, towards the left of origin. Minus 5 comma 0 is this point. Coordinate geometry you all have done, and I'll be connecting that with the end point A. Okay, and similarly the same approach I'll be applying for this, connecting the E with x-axis. Then only it will be called as a polygon. Otherwise this figure is hanging in the air, it's not at all a polygon. Okay,
Yes, ma'am.
so after 50, next class interval can be 50 to 60, a virtual class interval we have created by looking at the pattern. And here the class mark will be, okay, 50 plus 60 by 2, that is 55 will be the class mark. Okay, and the coordinate which we have to take will be 55 class mark, which we will be taking along x-axis, and along y-axis nothing, 0. Okay, so I am going to take 50 to 60 we are having, and somewhere 55 will be there, that we will be joining with E, and we are done with frequency polygon. Clear?
Yes, ma'am.
Yes, ma'am.
Please do this much first, and then I'll be telling you what to do with the next section B, how to represent that on in the same coordinate axis. Everyone, please do this much first. And yeah, let me know once you are done. Are you done, everyone?
Yes, ma'am.
Yes, Rishikesh, Lokya,
Yes, ma'am.
Farzuddin, Tanisha.
Yes, ma'am.
Yes,
Okay,
ma'am.
everyone done. Now, section B, I'll be representing over here only. Here only. Okay, so we understood how to, we have to, like, how exactly we'll be proceeding. We'll be taking the class mark along x-axis. That is, first class mark is 5. Okay, just leave that virtual class intervals and all. We will be doing that. Let's work with our data. So first one class mark is this one, 5. Okay, and the frequency is 5. Is it clear?
Yes, ma'am.
Next one. Next one, our class mark is 15. And the frequency is 19. Please represent these points now. Next one, our class mark is 25. And the frequency is 15. Next one, our class mark is 35. And the frequency is 10. Next one, our class mark is 45. And the frequency is 1. Okay, so 45 comma 1. We will be locating all this point. I'm going to locate it. So first one is 5 5. This. Next one is 15 comma 19. Okay, 19 will be the topmost beyond this one. Okay, next one 25 comma 15. 14 15. Next one 35 comma 10. Next one 45 comma 1. I'll be connecting all the orange color dot. Is it clear so far to everyone?
Yes, ma'am.
And yeah, we will be connecting it with the virtual class interval, which we have done. Here, since the class intervals for section A, section B are not different, so for this case also virtual will be same. And since the frequency is 0, previously as well, now also frequency is 0. So the same point we will be connecting. Okay, the same point will be connecting. Clear?
Yes, ma'am.
These are the two class intervals. I mean, these are the two frequency polygons for the given section A and section B. And this is how we will be plotting frequency polygon with the help, okay, without even taking the help of histogram. Is it clear to all of you?
Yes, ma'am.
Please do it first. Are you done, everyone?
Yes,
Yes,
ma'am.
ma'am.
Okay, here it says that from the two polygon, compare the performance of the two section. What can we say regarding the performance? Who will say? Anyone?
Section A is like has more mark.
Section A have achieved uh, better marks. Can we say that?
Yes.
Yes. Anyone else? Can we say section A have achieved better marks?
Yes, ma'am.
Okay, so yeah, in general, if we will see the graph, just by looking at the graph, you are saying section A have achieved better marks than section B.
No, 40 to 50 section has like more marks.
Okay, yes, this, wait, the frequency over here, the maximum frequency is lying in between, yeah, section A, that is 30 to 40, 40 to 50. So yeah, we can say they have achieved better marks, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, this is how we can give the final conclusion. And yeah, we are done. Let's do the next one. Just a moment. Let me take the next question. So we are done with this one. Okay. Now question number 7. The run score by A and B on 60 ball in a cricket match are given. There are two teams, team A and team B. Okay. Represent the data of both the team on the same graph by frequency polygon. Exactly, we have to do the same thing, but here you are you noticing the class intervals? It's not continuous. Can you see?
Yes, ma'am.
Okay, it's not
Yes,
continuous.
ma'am.
1 to 6, 7 to 12, 13 to 18, 19 to 24, 25 to 30. So yes, we understood how to represent it in the form of frequency polygon, and yeah, that too in the same coordinate axis in the same graph. But here, first of all, we will be making the data continuous before proceeding. See, whether you have to represent it in the form of histogram or frequency polygon, your data has to be continuous group data. So we will be making it continuous, and the process was find the gap. Gap what? Gap between the lower limit over here and the upper limit. See, this lower limit 7 and the upper limit of the previous class 7 and 6. 7 and 6, the gap is 1. Okay, so what we do gap divided by 2, that means 1 by 2. That means 0 0.5. Now we subtract this 0 0.5 from the lower limit and add 0 0.5 in the upper limit. Due to that, it will become 1 minus 0 0.5 will be 0 0.5. Okay, and 6 plus 0 0.5 will be 6.5. 7 minus 0 0.5 will be 6.5. And 12 plus 0 0.5 will be 12.5. 13 minus 0 0.5 will be 12.5. And 18 plus 0 0.5 will be 18.5. Making sense?
Yes,
Yes,
ma'am.
ma'am.
19 minus 0 0.5 will be 18.5, and 24 plus 0 0.5 will be 24.5. So this way we have to make the data, okay, continuous, and then we can represent it in the form of frequency polygon. For finding the frequency polygon, always we have to find the class mark first, because that's how we will be getting the coordinate form. While creating the coordinate, if you are getting confused that which you will be taking along x-axis and which one along y-axis, now recall that frequency we always represent along y-axis. So of course, while creating the coordinate format, we will be writing frequency along y-axis, right?
Yes, ma'am.
Yes.
Okay, and class mark is coming from where? Class mark, it's coming from where? It's coming from the class interval, that class interval only which you have located around x-axis. So of course, class mark will be the x coordinate. Making sense?
Yes, ma'am.
Okay, so you will be able to do this as well. Yeah, first of all, you have to make the data continuous, then you will be able to do. Now the next one. Number 8 we had already done. Number 9 also we had already done. So yeah, we are done with everything except that first three questions. Yes, Anand, to you I want to explain the first three questions. With rest of the students, we are done, right? Right?
Yes, ma'am.
Okay, so we are done with the statistics. Anand, I'll be explaining you the first three questions. Uh, I will be explaining it to you in the next class. Just do join on time. Okay, and I'll be just explaining the first three questions, how to just continue with the bar graph and all. Okay.
Okay, ma'am.
Okay, so yes, we are done with statistics. Okay, if you will have any doubt, any confusion, I am always there. You can ask me anytime. Okay, any time you can ask me. Either in the next class you can ask me, or when I will start the next chapter, in between you are practicing and you are getting confused, please do ask. The statistics is such a chapter, okay, which is really easy, but every time before any test, any exam, you need to practice this chapter, otherwise you won't be able to do anything. Okay, because so many statistical languages involved